Yeah, and I'm extremely honored to be here. Right, it's really awesome to be here. Kind of people who are privileged to attend the sessions as well. So we start with some quick short question. You know what? Currently, what's the world's largest taxi company? Uber. Yeah, Uber. It's for the students. Largest accommodation provider, popular media owner. Any clues on these? Airbnb, again not a student as well.
So we are not the right person.
Yeah. So what's common here, right? Uber, Facebook, Alibaba.com, Airbnb. What's common? What's unique about this slide? They don't own the content, right? Uber doesn't own the vehicles. Airbnb doesn't own the real estate, right? These are pretty exciting times. We don't. It's no more about the inventory. It's about the technology, the disruption that you bring in, into the domain that was matters. And AI, as we heard in the previous session, is causing a revolution. And one of the things that is triggering this is the kind of data explosion that we are seeing recently with social, with IoT, right? There's the health, the sensors that we are carrying for health, etc. And most of these data are going to be unstructured. We are very familiar with how to deal with structured data, how to program the databases, etc. But how do we deal with the unstructured data? That's where the natural language processing, machine learning, artificial intelligence, all of these are creating disruption, right? So we have got these sensors which brings in a lot of data. We have done data analytics for quite some time now. But how do we get this information into knowledge, right? How do we democratize this information into knowledge so that we can make business decisions using that? How do we make sense out of the large amount of social media information that's getting generated every second? IoT devices creating so many events. How do we make it into knowledge? How do we use this information better? Right? That's where the cognitive computing comes into play. We have so many different names. I'm from IBM, and we try to use the term cognitive computing. So pardon me with that new term that's getting introduced in the lingo. But just a brief introduction of Watson for those who don't know, right? IBM takes grand challenges, and one of the grand challenges for this century was the Jeopardy challenge, right? The IBM research team wanted. Jeopardy is a US-based game show. Some of you might have heard about it. Basically, it's a very complex kind of English language quiz show where they will give a sentence and you need to frame a question for that, right? And it's not a very straightforward thing. It's pretty complex, a roundabout way of asking something or mentioning something, and then you need to figure out what is being asked and then provide an answer for it, right? So it's pretty difficult for even humans to understand and then process, then find out the right set of answer and then provide the answer, let alone for machines to do that. So the IBM research team took it as a grand challenge, and in 2011 there was this Jeopardy game show where IBM Watson competed with two human participants who were from the Jeopardy history. Those two were the top human contestants, and then it beat those humans in that show, right? And that's where it took off. And then since then we have been working on how do we put that into solving real human challenges. We started off with the field of medicine, cancer research, helping doctors treat patients, and now we are into so many different things that I'll cover about. But I wanted to do a quick small 5 minutes video of how this Watson technology works.
IBM's Watson is at the forefront of a new era of computing, cognitive computing. It's a radically new kind of computing, very different from the programmable systems that preceded it, as different as those systems were from the tabulating machines of a century ago. Conventional computing solutions, based on mathematical principles that emanate from the 1940s, are programmed based on rules and logic intended to derive mathematically precise answers, often following a rigid decision tree approach. But with today's wealth of big data and the need for more complex, evidence-based decisions, such a rigid approach often breaks or fails to keep up with available information. Cognitive computing enables people to create a profoundly new kind of value, finding answers and insights locked away in volumes of data. Whether we consider a doctor diagnosing a patient, a wealth manager advising a client on their retirement portfolio, or even a chef creating a new recipe, they need new approaches to put into context the volume of information they deal with on a daily basis in order to derive value from it. This process serves to enhance human expertise. Watson and its cognitive capabilities mirror some of the key cognitive elements of human expertise. Systems that reason about problems like a human does. When we as humans seek to understand something and to make a decision, we go through 4 key steps. First, we observe visible phenomena and bodies of evidence. Second, we draw on what we know to interpret what we're seeing, to generate hypotheses about what it means. Third, we evaluate which hypotheses are right or wrong. Finally, we decide, choosing the option that seems best and acting accordingly. Just as humans become experts by going through the process of observation, evaluation, and decision-making, cognitive systems like Watson use similar processes to reason about the information they read. Watson can also do this at massive speed and scale. So how does Watson do it? Unlike conventional approaches to computing, which can only handle neatly organized structured data, such as what is stored in a database, Watson can understand unstructured data, which is 80% of data today, all of the information that is produced primarily by humans for other humans to consume. This includes everything from literature, articles, research reports, to blogs, posts, and tweets. While structured data is governed by well-defined fields that contain well-specified information, Watson relies on natural language, which is governed by rules of grammar, context, and culture. It's implicit, ambiguous, complex, and a challenge to process. While all human language is difficult to parse, certain idioms can be particularly challenging. In English, for instance, we can feel blue because it's raining cats and dogs while we're filling in a form someone asked us to fill out. When it comes to text, Watson doesn't just look for keyword matches or synonyms like a search engine. It actually reads and interprets text like a person. It does this by breaking down a sentence grammatically, relationally, and structurally, discerning meaning from the semantics of the written material. Watson understands context. This is very different than simple speech recognition, which is how a computer translates human speech into a set of words. Watson tries to understand the real intent of the user's language and uses that understanding to possibly extract logical responses and draw inferences to potential answers through a broad array of linguistic models and algorithms. When Watson goes to work in a particular field, it learns the language, the jargon, and the mode of thought of that domain. Take the term cancer, for instance. There are many different types of cancer, and each type has different symptoms and treatments. However, those symptoms can also be associated with diseases other than cancer. Treatments can have side effects and affect people differently depending on many factors. Watson evaluates standard of care practices and thousands of pages of literature that capture the best science in the field. And from all of that, Watson identifies the therapies that offer the best choices for the doctor to consider in their treatment of the patient. With the guidance of human experts, Watson collects the knowledge required to have literacy in a particular domain, what's called a corpus of knowledge. Collecting a corpus starts with loading the relevant body of literature into Watson. Building the corpus also requires some human intervention to cull through the information and discard anything that is out of date, poorly regarded, or immaterial to the problem domain. We refer to this as curating the content. Next, the data is pre-processed by Watson, building indices and other metadata that make working with that content more efficient. This is known as ingestion. At this time, Watson may also create a knowledge graph to assist in answering more precise questions. Now that Watson has ingested the corpus, it needs to be trained by a human expert to learn how to interpret the information. To learn the best possible responses and acquire the ability to find patterns, Watson partners with experts who train it in using an approach called machine learning. An expert will upload training data into Watson in the form of question-answer pairs that serve as ground truth. This doesn't give Watson explicit answers for every question it will receive, but rather teaches it the linguistic patterns of meaning in the domain. Once Watson has been trained on QA pairs, it continues to learn through ongoing interaction. Interactions between users and Watson are periodically reviewed by experts and fed back into the system to help Watson better interpret information. Likewise, as new information is published, Watson is updated so that it's constantly adapting to shifts in knowledge and linguistic interpretation in any given field. Watson is now ready to respond to questions about highly complex situations and quickly provide a range of potential responses and recommendations that are backed by evidence. It's also prepared to identify new insights or patterns locked away in information. From metallurgists looking for new alloys to researchers looking to develop more effective drugs, human experts are using Watson to uncover new possibilities in data and make better evidence-based decisions. Across all of these different applications, there is a common approach that Watson follows. After identifying parts of speech in a question or inquiry, it generates hypotheses. Watson then looks for evidence to support or refute the hypotheses. It scores each passage based on statistical modeling for each piece of evidence, known as weighted evidence scores. Watson estimates its confidence based on how high the response is rated during evidence scoring and ranking. In essence, Watson is able to run analytics against a body of data to glean insights, which Watson can turn into inspirations, allowing human experts to make better and more informed decisions. Across an organization, Watson scales and democratizes expertise by surfacing accurate responses and answers to an inquiry or question. Watson also accelerates expertise by surfacing a set of possibilities from a large body of data, saving valuable time. Today, Watson is revolutionizing the way we make decisions, become experts, and share expertise in fields as diverse as law, medicine, and even cooking. Further, Watson is discovering and offering answers and patterns we hadn't known existed faster than any person or group of people ever could, in ways that make a material difference every day. Most important of all, Watson learns, adapts, and keeps getting smarter. It actually gains value with age by learning from its interactions with us and from its own successes and failures, just like we do. So, now that you know how it works, how do these ideas inspire how you work? How can Watson make you a better expert? What will you do with Watson?
A few things that Watson tries to do, right? One is understanding, reasoning, and then learning. Understanding would involve understanding like how humans do. So in terms of if it's a written text, you need to have natural language processing, right? If it's voice, it needs to be able to understand voice or images. And then reasoning would be to involve the existing knowledge and find out for the given problem what is the right kind of response, and that comes from the learning that we do. And this is pretty much how humans learn and humans respond to problems, and that's pretty much how cognitive applications that like Watson are the ones that you can build using Watson needs to do. Right? So what we have done with this technology is we have created a platform out of these technologies for different areas of the problem and created them as an APIs, where you can bring in your own data, create your own service which is tuned to your data, and then focus on just the problem and solving your problem, and leave the heavy lifting on NLP and machine learning and all those stuff to the service itself, right? So it abstracts out the complexities of this technology and then provides it with a simple to use service interface that you can use for these domains. So what I'm going to do is I'm going to show some live demos of few of these services, and there's a big list of the services that you can look through offline, but I'm going to focus on a few of the interesting ones, and then we'll take up questions on how we can move forward. Okay. So let me quickly shift to the services. So it's still in the. Okay, so let me start with visual recognition, right? It's a It's a service that lets you not just identify things from images, which a lot of other capabilities are also there, but what is unique about this service is you can bring in your own set of images and create your own classifier which identifies which knows the images for your domain. So if you have a very specific use case, like identifying eye diseases based on retina scans, or in your heavy industry identifying specific parts or specific issues with your machineries based on just looking at the images. Or in this case, the example that I'm going to take is insurance claims. Let's think of car insurance claims, right? If you get into an accident or if there is any problem with your car, it's a pretty complex process to get the insurance claim done, right? You call or you contact the insurance company. They send some surveyor, comes in and surveys your car, and then based on their report, it gets approved, and then you can start processing. Right? Imagine if you can just take a picture of your damaged car and upload it into the insurance site, and it gets automatically approved based on what the problem that you described in your problem statement is. Right? How can a machine do that? The machine should be able to, with confidence, know that the picture actually shows a car with this particular problem, and that's exactly matching the text that the user fill in when he's submitting the image, right? And then based on the confidence threshold, it can then say, okay, I upload this automatically. So how can an image identify that it's a vandalism versus it's a broken windshield versus a flat tire or some other part? How can a machine do that? So we can, using this service, we can train a classifier which knows these different kinds of insurance problems. So I have these set of sample images, representative images for these 4 classifications: broken windshield, flat tire, something which is in which a motorcycle is involved, and there's a vandalism. And then I'm also providing some negative images here, which is in this case undamaged vehicles, right? And then I'm asking the service to train a classifier. I need to select this and then say train a classifier. So what happens in the background is these images gets uploaded into the service, and then it creates a machine learning model based on these images, right? It creates this classification which will know that based on these representative images of each of these classification, it creates a model which can then be used to identify any new image that comes in with any of these issues. So let's just wait for the classifier to.
Just a quick question. So
Yeah.
all the different classes that you created, they were already existing.
No, it's not existing. It's a demo application which has these images, but you can absolutely bring in your own images, create your own classification. So this is just a demo application. Thanks for asking. Right. So this was not an existing classification. This is something that we are bringing in when we are creating our own custom classification. Okay. And now let's try a new image. Right. So I'm going to do a Google search, image search, and pick an image which is a. So I'm going to put this URL here and ask the system to tell me what kind of image it is based on the classifier that I have created. Okay, so it says it's 96% confidence that it's a broken windshield and 93% confidence it's a vandalism. So remember this is a probabilistic system. This is not something that it has learned from the representative images that it is given. So from an application perspective, if you are building an application for the insurance company, then we can decide as an application developer how we are going to use this code, right? For example, you can say, okay, I have a threshold of 70%, and then anything above 70%, I'm going to use it as this, right? So here, the top one is 96%, so it's pretty confident that it's a broken windshield. So you can use this as this, and then if the user also claims that it's a broken windshield, then you can auto approve this, right? So yeah.
So in this kind of scenarios, when you're giving input, does it care and distinguish between whether the glass is a vehicle glass or is it a window? So I could take a picture of it, let's say cracked glass in a window, and I can give it there. Does it care to say this glass itself is a valid use case for you to look at it?
So the way you can do it is you can create a separate class for like a window broken window class, right? So you can create a separate. So based on our training data, we have a very small set of classification and just 4 classes, right? Based on our training data, my guess is if you give a broken any class, it's going to say broken windshield, because we have not taught the system that this is the differentiation of a broken windshield versus another broken glass. That we have not taught the system.
So it won't bother about the contour of other things, like in what context of visual image you are looking at the image, for example.
We have to teach the system that differentiation.
Yes.
Right? In our example, we have not taught it. But it's a valid case, right? In this case, we should have created a separate classification for.
Provide that.
Yeah, then it will be able to differentiate between a broken windshield and a broken glass, right? And then you can use that information. So so how do you use this service? And I jump directly into demo because that gives you an understanding of what it is. But what this is actually is one of the many services that's available in the Watson platform. We call it Watson Developer Cloud. You can get started by just googling on Watson Developer Cloud, and it starts listing out all the APIs that are available. If I just go here, there's a big list of APIs that are available. Every API has got its own set of demo application. That's also this is a demo application. You can the code is available on GitHub, so you can fork on GitHub, use it as a starting point, and start coding. There are APIs that are available in all popular platforms like Node.js, Java, Python. Right, there are APIs that are available. APIs that are available, and there is also documentation that's available for each one of them. So I can go to there's a documentation that's available which talks about each of the API. There's an API reference that's available. Right, these are all REST APIs. So you can build your own application. This is just a sample application that I showed. You can build your own application using these APIs, and make a call to these REST APIs. Apart from the visual, I showed a list, right? Let's look at a couple of other ones, and then I'll leave it to you to explore the other things. There is of course a conversation service that's available for creating the chatbots, and it does good job using machine learning of understanding the intents of the user, so you can train the system to understand various ways of asking the same question, and then you can create a conversation of what kind of response that you want to give for those questions using a visual builder that we provide along with the service. There are other services like tone analyzer. Let's look at tone analyzer. And again, I'll start with the demo, right? So let's take this sample transcript of customer service chat, right? We have had our own experiences with customer care, where they have a hard time understanding our problem. We get angry, we get irritated, the low customer satisfaction, all those things. Everybody is seeing that. But there's no way for companies are struggling to improve their customer satisfaction and to identify right at the start when the customer is getting angry and when the mood of the customer is changing, and when is the right time to actually escalate the problem to a better agent or a higher authority, etc. So in this case, let's look at this chat where the customer had a problem with somebody creating an account based on their email account, possibly a phishing or some other problem. But the agent had trouble understanding even the problem, and they're providing a different kind of solution for the problem. And the customer gets progressively more irritated as the call goes on. So let's analyze this and see how the tone analyzer service that Watson has can identify the tone of each of the sentences within the text that's provided, and then using that you can build build an application on top of this service for the customer service use case also, where based on the tone change of the customer, you can escalate that immediately rather than waiting for it to become pretty bad, right? So there's information around emotion, language, style, and social tendencies that are given for the document level and as well as the sentence level. So you can watch out for specific emotion tones, right? So for anger, disgust, right? There's email me if you have any follow-up questions or if you have any ideas that you want to discuss. Yeah, this question.
Sir, I wanted to ask what role does IBM Watson play in cancer cure and what is currently happening in that role?
Yeah, so what we did immediately after Jeopardy is we partnered with a few of the institutions, Memorial Sloan Kettering and a few of the cancer institutes, and use their doctors to train Watson on treatment plans as well as the test that needs to be done, etc. So we created a cancer kind of advisory with the Watson, and it's also there are a couple of commercially available things that other hospitals worldwide are also using. So there's an Indonesian hospital, Manipal Hospital. Yeah, Manipal Hospital in India is also using this Watson Cancer Advisor product, where it's more like an advisor to the doctors. Doctors, when they see a patient, the system will already go through their electronic medical records, prepare a plan for that particular patient, and also provide the evidence based on which this plan was provided. So the doctor can look at the suggestion, you can also look at the evidence, and it can the doctor can then provide that or overrule that also. So that's what we have done with cancer, and we actually formed a separate Watson Health where there's a lot of other health related things also that's happening.
So how do you collect data, and is the data which you have open to public or?
No, so we work with the specific hospitals. So the IP belongs to the hospital, and whatever the product is in partnership with those hospitals. We partner with the hospitals to get those data, and even training was done by the doctors. So for this particular patient, what is the best treatment? Right? For doing the machine learning, we need to do the training, and the training was done in collaboration with the hospitals.
There is also anonymized digital healthcare, not necessarily in cancer, but in other areas. That you can use that typically used in cancer.
But we have taken the approach of partnering, because we also need to have the SMEs, and we don't have them.
Okay, thank you so much.